Okay, so let's take a look at another example here. We're supposed to determine the total current and the phase angle in this circuit. In this case, again, we're given the inductor in henries, the resistor 2.2 k ohms, and they want us to draw a phasor diagram showing the relationship, of the source voltage and the total current. So, first thing we need to do is convert that inductor into an inductive reactance. So we do that. 2 pi FL gives us 1.41 k ohms of resistance. We're going to invert that so that we get its susceptance, and when we do, we get 709 micro Siemens of susceptance. We're going to do the same thing with the resistance value, 2.2. We're going to turn it into its conductance, so 1 over R gives us 455 microsiemens then. So from that we can calculate the total admittance, G minus J B sub L, 455 microsiemens minus J, 709 microsiemens. Convert that into polar form using our Pythagorean theorem, inverse tangent values. And right here we appear to be missing a -1. There should be a -1 right there, and I cannot get to it. So I apologize. So the Y total then should be the Pythagorean theorem inverse tangent. So 709 microsiemens, 455 microsiemens gives us a magnitude of 842 at an angle of minus 57.3 microsiemens. We can calculate then the total current. In this case, we just apply Ohm's law. I total is equal to the source voltage times the total admittance in this case. So 10 at an angle of 0 volts for the source, 842 at an angle of minus 57.3 degrees microsiemens gives us a total current now of 8.42 at an angle of minus 57.3 milliamps. Okay, so negative angle we can see over here minus 57.3, our total current 8.42, and our source 10 volts. Phase relationships of currents and voltages. So we can see here our normal analysis of a circuit where we've got the total current, the current through the resistor, current through the inductor. Okay, and we get our representative phasor representation of that current through the resistor, current through the inductor, and the total current. We put that in our phasor uh, rectangular format, I sub r minus j I sub l. If we need to convert it to polar, then we apply our normal conversion. Okay, the current directions shown in A are instantaneous, and of course the reverse when the source voltage reverses. So with those relationships, I total then, as we just stated, and our conversion, then we have our two components that we need to do a conversion from rectangular to polar. The phase relationships then of the currents and the voltage, you can see again that we have the current through the resistor in phase with the source, with the resistor voltage drop and the inductor voltage drop. Here we have the current through the inductor 90 degrees out of phase, and the total current as given by our relationship, our phasor polar relationship. Example then, determine the total admittance and then convert it to total impedance in the figure below. Draw the admittance phasor diagram. So again, in this case, we've got the inductor given to us in henries, so we'll have to convert that. So first we determine the conductance from the magnitude of R equal to 330 ohms. We then determine the inductive reactance using 2 pi FL, and we get 628 ohms when we do that conversion. The inductive susceptance magnitude then is the inverse of 1 over x sub L, which gives us B sub L for our susceptance. So 1 over 628 ohms gives us 1.59 millisiemens. So the total admittance for the circuit then is the conductance minus the J B sub L. So 3.03 millisiemens minus J 1.59 millisiemens, which can be expressed in polar form. Okay, so you would do your conversion. I don't know if I can get this down. Let's see. Okay, there we go. We can almost see it. Good, good, good. Okay, so we use our conversion, and then from that we can draw our phasor diagram. Converting the total admittance to the total impedance then is as follows: 1 over Y total, admittance total then 1 over 3.42 at an angle of minus 27.7 millisiemens gives us an impedance then of 292 at an angle of 27.7 ohms. Okay, another example: determine the value of each current and describe the phase relationship of each. So we've gone through this. I'm going to let you go ahead and do it. So pull out your calculator and go through these, verify each of the values here. As shown, you can see we're calculating the current through the resistor, the current, that should be not C, but it should be L, the current through the inductor, the total current then given in rectangular form, and then we convert the current to the polar form using this relationship, and we get 96.8 milliamps at an angle of minus 55.7 degrees. So go ahead and do that. Pull out your calculator, stop the video if you need to, and work through each step to make sure that you understand it. The last section then, we combine series and parallel circuits and determine how we calculate given that situation.